Hello from Romania, from your favorite artist electronics, Mr. Q12. What I have here, I made in reality this circuit that I'm having here pretty much. I retested this circuit here in Proteus, just to be sure that everything is working fine. And it is, everything is loaded correctly. Let's see, this folder I have here, and is this folder here, and you see this name. This is important for the simulation that I have here. And when I'm running it, doesn't say anything because it's on manual, but if I'm setting it to automatic there, everything is running perfectly. And if I'm changing only this potentiometer that I have here, this which is on input 0, this one here, if I'm changing it, it's only set. I will show you the code in a moment, but you can see here is showing the difference when I'm moving the potentiometer. And of course it's making double when it's catching that 0, 0. And I stop the simulation. And let me show you the code. So this is the code. It's exactly as it was before. Only that so the loop method is not used at all. I only use this in 0 here in 0. It's my name. This is not an official name. It's whatever name I wanted to put here. I can change it whatever. But it's looking a bit serious, too serious. But it's actually my thing. So I'm passing this into for the interrupt function. I'm using the interrupt here, and I'm instead of incrementing all the addresses between them, because if I'm scrolling down and if I'm looking inside this increment address function that I made, is cycling through 8 addresses, and I don't really want that, especially at this point when I'm testing if it's working in reality. And it is working in reality. It's working absolutely perfectly, exactly as in the simulation that I'm having here in Proteus. So that's very, very cool to actually test it in simulation here and then test it in reality. So this is what I did. I commented out this cycling through all the 8 addresses, pretty much this increment address function that I made, and I only use one function, the set address function here. You see that I made, that I actually use it inside that increment address. So I use it here. I set it on address 000. So all the pins right here, these green wires are the address lines, and they are set to negative, all 3 right now from the code. I had to add, instead of this, you see, this line that I commented out with my friend from England. He was extremely frustrated. He didn't manage to work in reality. The chip that he is having, like I said before, he's having ADC0808. It's a bit different from my chip, but not that much. Pretty much the same logic gets to that chip as I'm having it here. So he didn't it didn't work in this. This is called, how it's called, serial monitor from here. So if I'm closing this and if I'm opening like that, it's a serial monitor, and now it's reading actually my real Arduino. But if I'm not plugging in my Arduino here on the USB port, if it's not plugged in at all, this serial monitor doesn't show at all. Or I managed to weasel about it. I managed to put it on COM1, and it is showing without error, but it's not actually reading anything. So I cannot test my code on that COM1. I don't know what to use, but really it only works. This serial monitor works only when I have the Arduino plugged in, pretty much on the line, on the USB communication port. So the code right now is running. Well, it is compiled from here, is uploaded. So I'm compiling it, I'm uploading it. For the Arduino, for the simulation test that I'm having here, I only have to compile it and not to upload it to anything, because it doesn't require to be uploaded. It only needs to be compiled, and that's it. You read the hex file. But in reality, you have to actually upload the program. You upload it actually in this. You see that square there? In that square chip, you upload it. And pretty much I followed exactly this logic of wires that I'm having here. I didn't make, instead of 13, I put it on, I don't know, 2 or 3. No, I did it exactly the same wiring that I did here. So pin 13 is going, pin 13 from Arduino is going to out 8, is listening pretty much. This pin 13 of the Arduino is listening to this out 8, what is transmitting. And also this address pins, I link them exactly as they are here in this order, 5, 4, and 3 to this pins 25, which is, it means address A, 24, and 23. And how do I know everything where it is, especially on the Arduino chip? Because here it is. I'm having, where the fuck, because I'm not using them very often, all the time. And I forget. I'm filming with one hand, and with my other hand I'm moving the mouse around, and it's not good. So I'm looking here, where the fuck do I connect everything? And also I'm looking here, where the fuck do I connect everything? And where the start? That's why it's good to have 2 monitors, as you can observe. So if this is out 8, you see out 8 is there, is pin 17. By the way, I made this picture that you see here. You should make yourself check pin outs. I copied it from internet, but then I added to it in Photoshop, and it's very good to have a little bit of hint, important hints like this out 8 that I'm having here, and many others. The clock here with a little bit of drawing. It's very, you catch it with one eye, with one view. You don't have to number everything, and that's probably the clock. And yeah, so this out 8 is going to pin 13. No, yeah, it's listening. It is listened by pin 13, which is this wire. So from here. So from pin 13 is this small wire that is going on this LED that is not lit here. And this is on maximum, by the way, right now. And I had this wire, this black wire, I had it on that pin connected to to that transistor, and that is a NOT gate. Yeah, I disconnected this part of the circuit, so this part of the circuit is not doing absolutely anything. So I wanted to say that I didn't change anything in the circuit like it is in Proteus the diagram. All that I have right now, this part of the circuit that you see here, this part here is not connected to absolutely anything. Is not doing anything. Is on including that transistor here. But from this potentiometer, and this wire is not doing anything. Yeah, this wire is from the potentiometer. From here, including the oscillators, from this side here to here, including the Arduino, of course, this side here is exactly linked as it is in Proteus simulator. And I didn't change anything. That's what I wanted to say. It's very important. I had to put my oscillator, my small oscillator, on here exactly as I'm having it here on start pin. You see, on start pin I put the oscillator. Instead of pressing myself the button, is oscillating automatically. And also you can see that it is doing. Let me clear the output here. And you can see how slow. 1, 2, 3, 4, 5. You see, and is exactly when this is going off. In the middle, between on and off, in the middle of it, is actually writing one line there. I cannot film them in the same time. Or maybe I can. Let me try like this. You see? That's why it's good to have two monitors. Like this. Let me clear it out. And you can see probably both of them. You see? When that is going off, so when the LED is going off, is writing now. 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 You see? It's writing one line. And is when it's going exactly in the middle of going down from on to off. And that's when it's writing one line there. Let me clear the output. And if I'm changing, so if I'm changing the speed of the, that's why I wanted it to be on the same view, because if I'm changing the speed right now, I hope you can see. You see how it increased, and how that scroll bar is getting smaller and smaller. Let me clear out. You see how fast it's actually listening to those. Let me make it even bigger, like that. And now if I'm doing it like this, very very fast, when I'm resetting, you see. I'm keep pressing this button here, so this is very very fast, oscillating. But if I'm keeping it very slow, the minimum slow that it can do, if I'm resetting here, lowering this, is more readable like this. You can actually see what the fuck is going on, and if it's doing the job that it is supposed to do. So right now it's saying 1 1 1 and 1 0. You see this? You see here 1 1 1 and 1 0. You see that off LED is 0. So they are synchronous. They are doing the same thing in the same time. So if I'm next step, if I'm rotating the potentiometer, these LEDs will change. You see? Oh, let me actually put it. Probably, I don't know. Yeah, probably this is good enough. There it is. You see, 1 0 0 when it catched a 0 0. Well, it catched it there, but it got an error because I moved it when it was running. And now is those three 1 1 1. And you can see the other values. I hope. Auto scroll, motherfucker. No, stop from auto scrolling for the moment. But you can see the other values that they changed. So if this was all the time 1 1 1 1 0. It's changed to this line. You see, this is different. This is also different. This is definitely different. This is 1 0 0 0. 1. So okay. So now is 1 1 1 0. Yeah, it is. Probably the potentiometer moved. Yeah, you see, a little bit. The components, they can move themselves if you didn't know. Yeah, it's like a spring. It's springed out a little bit. So, but now I have those three. For some reason, this is flickering. Okay. Now there are 4 open. I know it's this 4, and here also should be 4. Yeah, this one. 4, but it is giving me some 0 there, probably from the potentiometer. For some reason, is not liking it. I don't know. Oh, it's very close to the margin. Oh no, come on, motherfucker. Yeah, stay like that. Is the 4th one. So you see, and this one came on exactly when you see it's flickering. For some reason, it's flickering that one. It's only 1 bit. It doesn't matter. But what it is important is that one that is pretty much in the middle. So is in parallel, what I'm reading on the serial monitor is in parallel with my display of LEDs that I'm having here, and they are showing exactly what I'm doing. Again, this is the oscillator that is set to 100 kilohertz. Is set for the ADC. Where are you? Here. This oscillator here. It is. You see? Come on. Yeah, in my simulation I set it to 10 kilohertz, but in reality I set it to 100 to be sure. I didn't test it with 10 kilohertz yet. In reality, I should. Actually, on my oscillator that I have there, I have 11, not 10. But it is close enough, So this is the oscillator that is for the clock of the chip itself. So this is what it's doing. Its only purpose is to clock the ADC itself, and that's it. And this secondary clock that I'm having here, this is the button press. It's simulating a button press pretty much. And instead of me pressing this button on and off, it's doing it automatically. And I believe, of course, these other 3 are not here in the simulation. I only have this one. And like I said, in the code is set only this address here, only on address 0. And of course, I can make it work for all the addresses, but we will have to wait until it will iterate through all the addresses. I show it here in simulation, and if it's working here in simulation, it will work in reality as well. I don't want to actually make the the test right now because it's not really important. What is important is that it's working and it's showing me this result while I'm moving this potentiometer here, this input. If I'm changing the input here, it will display the output. And as you can see, it reached the 0, all the LEDs are off, of course. And if it's reaching that 0, it's giving me a double new line. By the way, my friend from England, he was complaining about this in his code. It didn't work with /r. You see this /r and the other /r, or this one. You see this double /r. It didn't work with COM5 here, with this serial monitor. And for this to work, I commented this out, and I made it like this with serial print line methods that I'm having here to actually show one on top of the other here in the serial monitor. And he was having this problem. He also had a lot of problem with the Arduino itself because my friend from England, because he's not used to Arduino at all, and he is swearing on Arduino that is hard because he is new to it and he is not used to see. Probably to C language. If I understood correctly, and he only knows assembler. He's an old guy, very older than me, double the age that I'm having, and he really didn't get acquainted. But I made these movies, and he watched them, the previous movies that I made, and he watched them, and he made it work in his side. I forget what he mentioned, something that he didn't manage to actually switch from the code address. He switched the code from so he switched the code most probably from a wire address. So he didn't insert these 3 lines here. He actually wired the address directly to the positive or negative there, and he made that code of address, which address he managed it from those wires. And it's working like that as well with Arduino if you want to do it like that, because he didn't manage to make the code here. He didn't figure it out how to make the code from Arduino to transmit to that address, to a specific address, or to cycle through the addresses. Even though the code that I did here, it worked multiple times in my Arduino, in my Proteus tests that I did. And now, because he said it worked on his side, I got a little bit depressed a couple of days. I don't know why, probably the weather. It's spring right now, and and this morning I wake up and I did nothing else but setting up everything, figuring it out. I even had an error. I had this wire linked, like I said, to that transistor, and that transistor was keeping that line on all the time. And be careful with, and it was here. It was on the start pin. Here on the start pin, I should open the real. No, not you. The real circuit that I have, this one. I changed it a little bit. So this is the real circuit that I'm having right now on the board there. So I was having this line, this ALIA line. I was having it to positive through that 1 kilo, and it's not good. It didn't work. It was giving me all the time 000, the output here, like it's showing right now, exactly like it's showing right now. It was giving me 000, and well, I started to unplug back things. Until I managed to find that wire. What the fuck is that wire doing there? Let me take it out. And when I took it out, when I'm changing, well, the potentiometer was changed, and all the LEDs start to lit also, and also the serial monitor that I have here was starting to show things. And yeah, resolve the problem, But expect fucking errors, mostly from your inattention and your stupidity, because you cannot know everything in the same time. You have to do it step by step and figuring it out step by step, like I did here myself as well. So this is it, the implementation in reality with Arduino, and is working, and I absolutely love it. And pretty much that's it. Thank you very much for watching. Probably there is a code where I can show only 10 of these outputs here and then clear automatically from the code, not pressing this fucking button here. I have to research this little detail. It should be cool to have it, to actually clear the print line output, clear the output. I hope it is. All right. Pretty much this is it. Next, if I am to include increment address to increment through all the addresses. So if I will have to increment through addresses, that will be the next step. And yeah, and comment out this one that is doing only one single thing for the testing purposes right now. Alright, and I wanted to show you my setup that I'm having here. My box of wires, and my other board that I took out the wires from it, because this board was the chip itself when I tested it. And I took the wires and I used those wires to put it here. But I wanted to show you the general look, how it's looking right now, how all this stuff is here. This is my power supply that I'm using. I'm getting 5 volts, you see there, from there. These 5 volts are powering this entire board plus these 2 guys. The Arduino is getting the 5 volts from the USB, and I'm only connecting the Arduino negative ground pin to the ground of the power supply, pretty much. And this is called common ground. They are having Arduino, and that entire board circuit is having a common ground with Arduino. That's the only difference that I have here in reality from Proteus circuit, because in Proteus circuit you don't have to. They are assuming they are assuming it shouldn't work in Proteus if you don't common ground things, but it does work for some reason. It's a little bit misleading, because in reality if you don't do it, it will not fucking work. And pretty much that's what I wanted to show you, this general view that I'm having here. You see? Yeah, you understood everything that I did so far. Thank you very much, very much for watching, and see you later. All right, thank you very much. Hello from Romania, from the favorite artist.